So now we're gonna do example 2. It's about lemonade juice at a concentration of 9 degrees Brix is stored at 10 degrees Celsius and the concentration of ascorbic acid measured over a period of weeks to give the following results. From the table over here, we can see that the change of ascorbic acid concentration in milligram per 100 milliliter respective to the storage in weeks at 0, at 4 weeks, after 8, 12, and 16 weeks respectively. We can see that the concentration of ascorbic acid is decreasing with the respective storage time period. Therefore, over here, we're gonna deal with the reactant and not the product as in the case of example 1. The first question is to determine the rate constant for the loss of ascorbic acid, assuming that the reaction is a pseudo first order reaction. So no need for us to assume and make our assumption. It is already mentioned that we have to know, or it is determined that it is a pseudo first order reaction. For this, we're gonna use the following equation for the pseudo first order reaction, which is in slide 20. Ln A equals ln A0 minus K theta. Okay, we need to calculate the rate constant assuming that the loss of ascorbic acid is a pseudo first order reaction. The rate constant means K. In order to get out the K, ln A minus ln, just to make it better, minus ln A0 equals minus K theta, implies ln A0 minus ln A equals K theta. Therefore, K is equal to ln A0 minus ln A over theta. Now, how can we start, or how can we continue? We're gonna take the values as we said in example 1 in order for them to be more representative, the last value and the middle value. The last value means a theta equals 16 weeks. And we substitute them. K at theta equals 16 weeks equals ln A0. A0 at theta equals 0 here, 52.9. Ln 52.9 minus ln A at theta equals 16 minus ln 26.7 over 16. Using the calculator, the value would be 0.043. This is a rate constant. Then at the middle value of storage at theta equals 8 weeks, again for the data to be representative, K is equal to ln A0, which means ln 52.9 minus ln A at theta 8 is minus ln 38.3 over 8. Calculating here, the rate constant would be 0.04. Okay, so it is a little bit modified from the middle to the end, and maybe if we calculate it at each respective week, then each respective time of weeks where it is stored from 0 to 4, from 4 to 8, then we might see more modifications in the rate constant, and this is so normal in the case of a first order reaction. The second question, part B, is that we have to calculate the time for the ascorbic acid concentration in the juice to reach 20 milligram per 100 milliliter. So we need to calculate theta that is needed to reach 20 milligram per 100 milliliter, assuming that this is a critical value of ascorbic acid. So we are dealing with the following equation, which is K equals ln A0 minus ln A over theta. From this equation, we can have a theta S. We are going to calculate like the shelf life or the time that is needed. It's just the naming that is different to reach a value of ln A or A that is equal to 20 milligram per 100 milliliter. So theta is equal to just substituting ln A0 minus ln A over K. Substituting these values, we have ln A0 from the beginning, it is 52.9, yes, I can get it from there, minus ln 20. Now the K, what value we're gonna take for K? We're gonna take the average that we have found previously, 0.043 and 0.04, which is 0.0415. So theta S, substituting the values inside, we get it 23 weeks. So the time that is needed for the ascorbic acid to reach a 20 milligram concentration per 100 milliliter is 23 weeks.